Did you know that companies using MLOps see 30% faster deployment rates? That's why tech giants like Google, IBM, and AWS rely on MLOps to power their AI deployments. But what exactly is MLOps and how does it work? So in this video, we will break it all down from what MLOps really means to the roles in MLOps and the critical stages that take machine learning models from the development to the real world impact. Also, if you want to master MLOps for scalable AI, then check out our free masterclass. In this masterclass, you will learn how to use MLflow for models, Docker for deployment, how to build the production pipelines, serve models via APIs, and much more. Check out the free masterclass link in the description to enroll now.
MLOps is basically machine learning plus development plus operations. Together, we will call it as MLOps. MLOps basically means putting your machine learning model into operation via a continuous integration and continuous deployment. And looking and taking care of security as well as reproducibility, as well as data versioning, as well as model versioning, and being able to switch between different models. Okay, train the models automatically rather than we going ahead and waiting for it to be able to give the response or making a manual change. It is important that we have the response coming out in a automated way. So collaborative and experimental. First thing, you need to be collaborate. You need to keep on experimenting, automate as much as possible so that we can avoid manual intervention. Look for continuous improvement of ML model. The model that might be working today to be able to predict the price of a car might not work tomorrow if there is new feature that is being introduced into the car. Okay, just to give an example. Okay, so ML models need to continuously improve based on the new features that are getting generated. Finally, we need to put everything into production, and for that you need to have standardization and scaling of those models that has been improved, tested, and now can be put to production. So MLOps basically looks into the three aspects: machine learning and data, build, automate, rework, and verify is development, and operationalize, basically release the product of the code, okay, onto an infrastructure, monitor it, and based on the monitoring, go ahead and retrain the model whenever it is required. That is one of the things that you need to understand with respect to ML ops. Basically, the requirement for any ML ops is that we need to create models that are scalable. Okay, people can collaborate over the code, over the data. Okay, and make it reproducible. Okay, so any model that you create, okay, can be upscaled onto VMs. Okay, people should be able to collaborate, and once the collaboration is done, the results that we get out of the model should be reproducible. Okay. And for this, we do have multiple principles that has been laid down, the tools and the techniques that make models scalable, collaborative, and reproducible. First thing what you can see here is this is the only one aspect that people are looking at code. Apart from that, collecting the data, verifying the data quality, okay? Even doing feature extraction from the data, extracting important features and rejecting some features, using the infrastructure like Kubernetes maybe, okay, or deploying the infrastructure as a Docker image on Kubernetes, okay, and monitoring the model from the configuration, okay, wherein we set up the requirement of the system, and finally we get the model that we want to go ahead and monitor. Everything is part of ML. Okay, that is one thing that we need to look into apart from just looking into ML code. So when we say basically the first step of any machine learning system is you need to discover what is the problem? Then you need to go ahead and look into the data and clean the data. The third aspect that is very important is machine learning pipeline build. Automate that process of fetching the data and being able to build a model automatically. And finally, put it to production. Okay. Before that, we will put it to, you can say, test infra. Then we'll put it to deployment infra. And then we will also try to monitor the deployment infra. Okay. So when we say use case, we need to understand the business use case. Has anyone tried this problem earlier and being able to get the response? Okay. What are the use cases? Okay. The point is, suppose I want to go ahead and build a fraud analytics system. So I need to understand how much time do I have? Okay. Apart from that, the quality of the data that we have. Okay. Is there anyone who has tried similar kind of case and failed? or was able to create a successful model. Understanding the data with by speaking or connecting to stakeholders is so much important. And finally, being able to understand what is feasible and what is not feasible. All this will come under business useful. Data engineering is very important. It prepare the data. When you say prepare the data, you remove the missing values, right? You include the missing value, you remove the missing value, you standardize the value, basically normalize the value, everything you look when you go for data preparation in data engineering. Then data engineering and machine learning pipeline, if I'm talking about, prepare the data, clean the data, normalize the data, use the algorithm will be best suited for the kind of target variable that we have. If it is a continuous variable, we can go ahead with regression. If it is a classification problem, then we can go for clustering. Okay. Yeah, classification, we can go for classification. With decision tree, random forest classifier. So you learn which algorithm to use. You build a model. Okay. Basically train or build a model. When you play with the model, right? The experiment. Basically, you do hyperparameter tuning. Finally, you evaluate the performance of multiple models that were built after the experimentation, tuning the hyperparameter. And based on whatever has been evaluated, the best model, once it is being tested, okay, onto multiple, you can say environment, testing environment, maybe for a small amount of user, you would like to evaluate the performance in literal sense rather than just testing on the test data. You would like to test it on a real sense. And then once you're happy with the performance, you will serve the model. The second step. Third is production deployment and production monitoring. Right? When we say about production deployment and monitoring, you deploy the model. This point of time, you do the automation, operationalization, making use of YAML file. Okay, you monitor the model, and based on the performance, you would like to go back to the model, get training, optimize it. If there is any, you can say, performance issue that is happening in the model, maybe the model is predicting something which is real. So you would like to go ahead and operationalize that via optimizing the performance of the model by going back to the model training, maybe preparing some new data, okay, retraining the model, then going ahead and again putting it to production. So this is the cycle. Now, the point that is very important is when you want to train a model, there are two things that are important. Not just the algorithm and the model that you have selected and the parameter. There's also something called as data. So data and machine learning go hand in hand. Data validation. How good is the data? Okay. Have you done the correct, you can say, cross validation of data so that you can use it to go ahead and train multiple models and check the performance of the overall system? Okay. Have you done transformation, remove the unimportant feature? Okay. Okay. So if you remove the feature or the feature engineering, all those factors will be important from the data side, which will be eventually used at the time of training. And then selecting the correct algorithm, hyperparameter tuning of that algorithm. Okay. And when I say algorithm, basically means there is an architecture. Shall I use a TensorFlow? Shall I use a scikit-learn? Shall I use a PyTorch, which will be more suited for my kind of need? Shall I really go for deep learning TensorFlow or PyTorch if the problem can be solved easily by a scikit-learn model? So architecture that you select based on the different, you can say, frameworks that are there is also very important at the time of training. You train and you get a model. Once you get a model, the next part is tuning the model. I did say you right. You tune the model. Okay. Basically, when we say tune, we look into how good is the model performing. Or is it fast in response? Is it taking time in the query to get the response? Okay. Apart from that, is it posted on proper GPU capabilities in place? So you analyze the performance and then you tune the model and then finally you put it to deploy. Now, just to give you insight about again one more important thing, this again goes hand in hand with machine learning, data ops. Okay, DevOps is applying DevOps to machine learning will give you MLOps. Data ops basically implies to put the set of rules that will ensure high quality of data. Okay. If you want to ensure high quality of data, okay, then you need to have operationalization of the data also. So there is also something called as data ops. So we are not looking into that, but this is again a very big field wherein people are looking into operationalizing the data, passing it through a multiple set of rules. Just to give an example, we can set up a rule wherein we can say if there is any feature with high cardinality, automatically reject it. We will not even consider that feature. So we can set a rule so that good quality of data enters into the system. Based on that, the script has been designed, tuning has been done, and then the model deployment, testing, and putting it to production happens. So data ops is important, acquisition of the data, understanding the performance. So based on the acquisition, which features are important and non-important, then will be very important when we say data ops. What are the different roles that we have in MLOps? Data scientist, model user, okay, data science manager. Again, there are whole lot of things that can happen, right? So an MLOps person, okay, can be a data science manager who is looking into operationalization of machine learning model, wherein the person is interested, is this prediction trustworthy for me? That's the only thing. Even this person is part of MLOps, wherein he is trying to understand whether this is worthy for me. Okay. Business stakeholder, if you deploy this model, what value will it bring to me? Support team, to give an example, how do they use MLOps? Yeah, why did we mark this as spam? Just to give an example, suppose you had an email, it was marked as spam. Why did it happen? Machine learning model might have seen some words based on which it might have triggered that this is a spam. Compliance, is this model safe to you? Compliance team, data engineer, from where do we get the data? Product manager, what are the limitations of this product? Data science manager, when should we retrain? Is there any algorithm to use? Is the model performing pretty well or not? All these roles are part of MLOps in general. All right, guys. So we'll look into different stages of MLOps. Okay. In this stage, we actually go ahead and you can say the focus will be when we say version control, we will version control the data, we'll version control the model, and we will also, to be very frank, version control the script, which is actually that. Okay. So first stage is version control of data and model. Okay. So that we have reproducibility. When we say auto enroll, here you are going to go ahead and write a script which is going to automate feature engineering, model selection, hyperparameter tuning. Okay. All those things will be there. Okay. Third thing is if you have this stage, you can move from AutoML plus version control. Here you can have model serving also. So here, apart from doing automated machine learning and version control of, when I say stage number one, this is where maximum of the companies stop. Okay. They do not go after the, like once they have versions and models, they do not want to automate it generally. Okay. They are okay with the results and they do not want to put it into production because of the complex nature of machine learning projects. Okay? So they can stop here. But if you are good enough, you can automate those processes. Okay. Using AutoML. You're more than good enough, then after doing version control, you would like to serve the model as an end product via the bench on real-time instances. And if you're more than that, you can go to fourth stage, which is version control, automate the flow, okay, serve the model, and even monitor the performance of the model. Okay, so that can be different things, stages that can be put into production. Okay, the first is, if you can see, data collection and preparation. Okay, when I say stage number one, you can see the same thing. Stage data collection and preparation, when I'm talking, you will have the data in the raw format. The data can come from Facebook. The data can come from, you can say, Twitter. The data can come from GitHub or maybe from any other source. The point is, we need to go ahead and convert this kind of data, okay, which is coming from internet, multiple sources, Twitter, Facebook, mobile, I don't know, IoT devices, from so on, and you need to have the data in a very nice format. This is the most toughest part. Just to give an example, I'll use a very simple layman example for all of you. I am going to say, suppose I have an image. Okay, I'll just put it this way. I have an image. In this image, I'll just put it this way. Suppose this is a man. Okay, this man is sitting. Suppose this is the table. Okay, and this man is actually sitting on this table. I'll just put it this way. Okay. So now if this man is sitting on the table and I have an visual system, I've created a visual system. Okay. And I'm able to get the response from this. Want to get a caption. Okay. So what is the caption that I'm able to get? I do know that the caption, suppose I have got the caption, the man is sitting on the bench. Okay. Is sitting on the bench. Now, if I have this, now if I ask you, what is the sentiment? You can say it is neutral because he's just sitting. Okay. He's not crying, right? So we can say the sentiment, if I ask you, you will automatically say it is neutral. Okay. Second thing that I would like to say, suppose I want to know what is the key phrase. Okay. If I say key phrase, you can say that key phrase is the man is sitting. Okay. We have sentiment, we have key phrase. Then comes the next thing. Suppose I want to know the language. Okay. And if I ask you, you can say that the language is English. Okay. Of the text. I have this information. So now this information that I already have, suppose I had an image and I had this tag. Okay. Now, if I want to put, suppose there are tons of images, can I put the same thing? I run it across a system and I was able to find the sentiment. Suppose I did a manual intervention, the key phrase and language. Now, if I put it this way, I have images. So I'll just say serial number of image. Okay. This is when I say serial number, you will say one. Okay. Next comes, I will say sentiment. Okay. Then I'll say key phrase. Then I will say language. Okay. So we have this thing. Okay, just to keep it simple, I do have this all things in. Okay, so I can say key phrase and sentiment. Now think about this. There were tons of images. There were 1 million images. Now think about what have we done? Instead of having an image and we had a text, and now we are able to go ahead and convert this into a tabular format. So the point is there is no machine learning without data. And if the data is raw, you need to convert it into a form that your machine learning model can understand. So you need to organize the data into a structured format. The raw data cannot be used directly. You need to reduce the data in a proper form. Even generative AI system are expecting the response in a particular format. You might have raw data, but they are expecting the data to be presented in a particular format, though not in a table, but yeah, in a JSON particular format they want. And then you can go ahead and train a model, and then be able to serve the model and even govern the performance of the model. This is the first stage that I'm talking about. Okay. Now, once you have this feature, you can automate this, right? And for automated, you have automated machine learning. Okay, you have lots and lots of softwares that are available. Splice machine, automated machine learning. Google has Vertex AI. AWS has their own, what you can say, machine learning processes. Okay, automated machine learning processes. PyTorch is being provided, which is an open source automated process. Okay, so once you prepare the data, collect the data, okay, you would like to have the process automated without manual intervention. And for this, whatever features you were able to create, you will store it in the feature store. Okay, after storing it in the feature store, now what do you have? The stage two comes. Automated development. This is what I'm saying, automation of the code. Okay, automation of the whole process. So now you have the data. You have stored the data in a feature store. You will explore the data. If there is any feature store that is required to be incorporated, you will select that. Okay, and then you will train the model, and then finally you can evaluate and test the model. For this, you can make use of automated machine learning and MLOps, to be very frank. Then comes very important thing. Once you have the model in place, you would like to call this model via an API. You would like to serve this model on one or more infrastructure, and the response on the model and the data needs to be monitored. So the application response that it gives, whether it is biased or non-biased, whether it is ethical or not, that can be evaluated. Apart from that, looking into the model and the data based on the response is also very important. Okay. So the third thing is once the model has been created. So if you remember the first stage, collect the data, collect the data, prepare the data. Second is automate the process. Okay. Third is create machine learning process. Create a machine learning model which can be automated. Okay. Once that is done, then you can look into the performance. Just to show you, I had a model version V1. Performance was dipping. I set the threshold as 0.5. What did I say? If my upfront score goes below 0.55, I would retrain the model. Pass some new things. I'll do some changes. Again, I would like to get the performance up to a level. Okay. If it is up to a level of 1 or greater than 0.6, I'm okay. So this is where the model retraining happens. Okay, then deployment thing and putting into production, all things happened at this point of. So the moment a model degrades at a particular level, you would like to retrain. So version 2 you came with. Again, after some time, you found in Jan, Feb, December it was working. In Feb, again the model got diminished. Right now, you can see lot of fluctuation, 0.1 to 0.6, but generally it will be 1 to 2% of fluctuation, not more than that. Okay, just to make you understand, we are showing so much fluctuation. So what are you doing? You are working on the model and monitoring the model, retraining the model, and then again after retraining, putting it onto production and seeing that it meets the threshold is also important. Now, what are the tools that we are going to use? So we are going to make use of Python. You need to install Python. We will use Docker, so you can install Docker. Okay, MLflow if you want to install, I'll show you how can you install. Hyperred if you want to install, scikit-learn you need to install, data version control, evidently AI and Bento ML. All these other tools, there are more than this, but some tools that we are going to use are being specified here.
Alright, so we have covered what is MLOps, roles in MLOps, and the stages that turn raw models into reliable AI solutions. Now, if you want to get personalized guidance on breaking into MLOps, then click on the link in the description for a career roadmap call with us. Now, if you found this video helpful, then hit that like button and subscribe and share it with someone who will benefit. And if you have got any questions or thoughts, drop them in the comment section below.